you by thesis123.com. I learn and teach online.
Here's the next question, number 22. The self-inductance of the primary winding of a single-phase 50 Hz transformer is 800 millihenry and that of the secondary winding is 600 millihenry. The mutual inductance between these two windings is 480 millihenry. The secondary winding of this transformer is short-circuited and the primary winding is connected to a 50 Hz single-phase sinusoidal voltage source. The current flowing in both the windings is less than their respective rated currents. The resistance of both windings can be neglected. In this condition, what is the effective inductance in millihenry seen by the source? So we have our options given A, B, C and D, and all these four options are given in terms of millihenry into 10 power minus 3. So let's begin by writing down what's given to us along with a circuit diagram that describes the situation here. So we have inductance L1 as 800 millihenry. We have inductance L2 given to us as 600 millihenry and the mutual inductance M is 480 millihenry. That's what's given to us. The self-inductance of the primary winding is 800, the secondary winding is 600 and the mutual inductance is 480 millihenry. So we have three values given to us. Now let's put them in the form of a figure or diagram. Now we have, let's consider this as the primary resistance, primary side. Here we have X1, X2, secondary side, and we'll call this as our load with impedance ZL. The current here is I2, the current here is I1. Those are our terminals and we have our mutual inductance given to us, M. Okay, so this is a very basic diagram. Now we need to find out what the effective inductance is. Now in order to find out what the inductance is, effective inductance, we have to work it out in terms of the reactance of the primary and secondary side. So if we are to consider the inductance of the primary side, inductance of secondary side and the mutual inductance between the two, we can write our formula, our expression as XL, now this is effective, is equal to JX1 primary plus omega square M square divided by JX2. Now omega square M square is with respect to the mutual inductance. So this is our expression. Let me just mark this since this is important. You can treat this as a basic formula. Okay. So let's take J out as a common term here. Now if we take J out, what happens? XL becomes J times X1 minus omega square M square divided by X2. Now let's calculate what the values of X1 and X2 are. Since we already have the value of M given to us as 480 millihenry, let's find out what X1 and X2 are. So here I'll write this down on the side here. X1 is 2 pi FL1. So we have the value of frequency as 50. So that's 2 into 3.14 into 50 times, this is 800 milli, so that's 0.8. X1 then comes around to 251.2. So that's X1. Next, let's calculate the value of X2. The formula is 2 pi f L2, which then gives us 2 times 3.14 times 50 times, now L2 value is 600 millihenry. So we write that as 0.6. So solving, we get x2 as 188.4. So we have the value of x1 and we have the value of x2. We also have the value of m, 480 milli, which is 0.48. Now let's substitute all those three values here along with omega. Omega is 2 pi f, which is 2 into 3.14 into 50, and that gives us 314. So let's substitute all of these values into this formula here. I'll note that down here for you. Okay, so we have XL, the effective inductive reactance, is equal to J into, we have the formula is x1 minus omega square m square divided by x2. Let's substitute the values. XL is equal to J into 251.2 minus 314 square 0.48 square, because mutual inductance is 480 milli. 480 milli can be written as 0.48 divided by 188.4. Okay, so I leave the solving part of this to you, and this gives us XL is equal to J130.624. Once you solve this entire thing, we get XL is equal to J130.624. Now XL, if we are to expand, we can write this as 2 pi f L effective, right, if we expand it. So that's J is equal to J130.624. We need the value of L effective, so this would be 130.624 divided by 2 pi f is omega, which is 314. So solving this, we get 0.416. And since the question asks in terms of millihenry, this would in turn be written as 416 into 10 power minus 3, which is 416 millihenry. And this matches, I believe it is option, yes, it's option A, 416. So this is the entire solution, and I hope it has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.